the principles of where a laser are used. And one of the things I want you, if you don't remember anything else that I say to you, just remember that a laser or an accessory is used from the very first moment a surveyor comes on that job site to walk that job site to the very last piece of sheetrock or drywall. So you have something to sell that user on that job site at all times. If you drive onto the job site, the surveyor's there, ask him, where's he getting his grade rods? You have grade rods to sell. So that's an important element, because there's probably not many other things that you can go from soup to nuts like that from the beginning to the end. So what we're going to talk about today, we have a couple different techniques. We have set up a batter boards over there behind the building there. We're going to do some elevations, and we're going to talk about how elevation is used. And then we have we're going to come over here and we're going to work some layout on how it's used on the where we've excavated. So there's main principles behind job site is contractors always looking for 5 major elements. Level, so it's got a level plane. Elevation. Alignment, so he's got to be aligned. He's got to have grade, how much grade it is, and we'll go through that right here. And then distance. So those are the 5 principles that contractor is looking for. And how do they do that? Initially, in a building like this right here, how do we know it's got to go on that right there where that position is? This is the big lot that they've come in. Got a bunch of dirt here, or grass and whatever. Surveyor comes in initially. He takes his readings. That surveyor is reading his points off of some marker that could have been even a mile or half a mile away from here. It's some kind of stationary point that the U.S. Geological Survey has put into the ground. Transfers that point to this site, and he's got some blueprints that the architects told him that they want to position that point. And he's going to put in a couple of hubs. Those hubs that we have represented are going to be over here, which we'll show you is one hub. And that hub is going to give everything in relationship, or that building in relationship to that hub. So you've got your blueprints, and you'll see this tomorrow when we do our inside presentation. So you'll see examples of this. But he's going to take that hub and transfer the points of the building. So he's got the building laid out. The surveyor will, and now the contractor comes in. Well, the contractor now has to start to work on elevation, right? He wants that building level. We just heard how important it is to have a level surface. You don't want the dips and valleys because you have water and things like that. Plus, another reason is you can fill in concrete with, or fill in the dirt with concrete, but at $125 a cubic yard, that's expensive fill, right? So you want that surface to be as level as possible. How are we going to do that? Why don't we start now? First of all, there's the first method, which is using an optical instrument. We have set up right over here 2 auto levels. You can walk over in here to, there's one right here and one over here. We'll start here, and then I've got them both set up so that you guys can both look through. But an auto level is an instrument like this. I'm sure you've all seen this on the job site. Very popular. Been making these things for 50 years. They're common to in roads, on a section of the road, just a short section or something like that. Very commonly used. And what do we have here is we have, just like a gun scope, look through one end, magnifies the lens, magnifies the inside, and I'm going to look at over here by where weight is where we're looking at a grade rod. And that grade rod is going to have readings on it. When we go over there, I'll show you what we're talking about. The auto levels come in different magnifications. So an important question to ask your customer, and by the way, I get this phone call probably once every 10 days. I've got a customer that wants a transit. Well, transits, there are things called transits that measure angles up and down, left and right. But contractors use the word transit like Kleenex. So an auto level could be sometimes a transit. You got to ask, do you want an auto level or do you want a transit? In many cases, they refer to auto levels as transits. So theodolites, which measure just angles left and right, up and down, are also transit. They call transit. So kind of clarify what your customer's looking for. Auto levels come in different magnifications. This one right here is 24 magnification. The one over there is 20 magnification. 28 is common, and 32 is common in the industry. Typically, most of your customers, the general guys are calling on are going to use 20 to 28. Get it to 32, it's more of a surveyor's instrument because he's usually looking at a much longer distance. So he wants to bring that a little bit closer. And what happens is it becomes more difficult to take a reading on a grade rod when you magnify it up that much closer as we are at this distance. So the ones you guys typically would probably focus it on a 20, 24, and 28, maybe 24 and 28 are the sweet spot there. Typically what you have to do is I've got my auto level, I put it on my tripod. Again, remember, that surveyor also uses tripods for his instruments. So not only grade rods, you got tripods. So if you pull up on that job site, ask him what kind of tripods he's using. So I put it on my tripod. I level my tripod as close as I can. You want to get this, fairly flat surface to the eyeball. And I've got 3 little wheels right here. So what I'm going to do is I want to level this beam, and I have a little level dial. If you guys, there's one. Well, if you want to come maybe closer to me, you can probably see a little bit better. But there's a little level dial here in this window. Turn this around. So, got a level dial in that window right there, and I've got a little mirror here for us short guys, so we can see where that dial is. I'm going to take these wheels, and I'm going to level that in the center of that level dial. Okay, it's just a regular dial, similar to a carpenter's level, only with a spirit right there. So I'm going to level it in one direction with these 2 wheels in the parallel to these two rotation wheels right here. Then I'm going to turn it 90 degrees because I've only leveled it in this plane. I've got to level it in this plane. I'm going to do the exact same thing with this wheel right here until I get that in the center of a little circle in that vial. Once I have that leveled in both of these planes, it automatically inside that unit levels itself. So it's got to get within, that bubble valve has to get within a range, gets in that range, it levels itself, turn it 90 degrees, do the exact same thing. So now I'm ready I've set up my auto level. I need to now take some readings. And we have right there the hub or benchmark that we're working from. So as you can see, it's a stake here in the ground that the surveyors put in, and that's giving us our predetermined elevation point. I need everything. I need all of my batter boards to that elevation point. So how do I figure that out? First of all, I've got a grade rod, and I'm going to take a reading from that auto level. But when you're talking about grade rods, just keep in mind the grade rods come in a couple different styles. One is they're aluminum, like this grade rod. Fiberglass is common, especially when they get into 25, 35, 40 feet, because you don't want to hit those lines and fry yourself. So fiberglass for the longer length grade rods are more common. That would be used when you have elevation changes significant on your job site. But in this grade rod right here, you can see it says 4 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 5 feet. So this grade rod is broken out into tenths. So it just gives you an easier ability to read because it's not in inches. So grade rods come in tenths, but they also come in when you would see 4, you would run up to 11, and then would say 5. So I could also get grade rods in inches, and also get them into metric. But I'm sure none of you guys, unless you're maybe in Detroit selling across the border, are selling metric. So that's the different styles of grade rods. So I'm going to come over here first of all. I'm going to take my initial reading. And I want to get this as plumb as I can. And somebody can you look in there and just take a look and see if you can see yeah. Can you see the grade rod? Can you get a reading off of it?
No.
Okay, let me. You look through this end of the auto level. Now this is for adjusting, the sight,
Not really.
Yeah, there's the reason, because you couldn't see it. It was out of focus. There we go. So, I'm reading this grade rod, and it says right now that we're at 4 feet 2.5 inches. And if you take a look, go ahead, take a look in there. You'll see, and you can see. You see it says 4 feet, and then you measure up the hash marks.
Yeah.
So it's 4 feet 2.5. We got to remember that in our head. So why don't you guys right now? The first part is you can split up into 2 groups. There's another auto level right there. You can always work off the same grade rod, but just see how that reading is. And I'm going to transfer that point over to here, because this is where we're building the building. And theoretically, it wouldn't be as close, but this is where we're building the building, not over there. That's where the surveyor's put in his benchmark. So I want to come over here. Thank you. And take my readings on my batter boards. So somebody look through there. Can somebody take a look through there and tell me what they see as a? The first you got to line it to this point over here. Can you read it?
Yep.
Is it 4 foot? It should be 4 foot 2.5 inches. It's a little bit high?
Yeah.
Okay, that's good. So what we want to do in this case is come over and just pound it in a little bit.
Tenth of an inch ain't very much.
Not there.
Is that
All right. So now I want somebody else to come over here and grab this grade rod, because we have to level this entire area here. So the batter boards. So hold that palm. Somebody else want to take a look in there? That should be high, isn't it? 4 foot 2.5. It's probably focused in my eyes, and I can't see a damn thing. You can't either. You want me to get it focused again?
Okay, yeah, we're right off of, we're still at 1 line off of 3.
So you gotta come down.
Yeah, we can come down.
Yeah.
How far?
Tenth of an inch.
Now you can look through there. You can go ahead and continue to look through there while he's hitting.
Yeah, that'd be good enough for my project.
Okay. Okay. So what we've done now, and we need to take multiple readings on that. We won't do it for the sake of time, but we got to take multiple readings on that batter board to get it all level, because you want it important again to have it level. So what do we have here? A couple of things. One is, which I didn't show you, there's gun sights here, so we can align ourselves if you just look through there with one eye easily to that receiver, or to the
with your line.
with your grade rod, right? I had to level my auto level. I have to find my benchmark. I've got to level my surface right on the batter boards, right? And then I have how many people? 1 person, 2 person, and probably 3, maybe, let's say 2.5, because not everybody's going to have a grade rod, a rod man, and a person use the hammer. But chances are that to get themselves set up, and they'll want to do this in a large building like that, they probably will have 3 people, right? So now, what are the other methods that you'd want to use? This is where lasers come in. This is
Come down just a little whack.
This is a really efficient method for doing a small area right here, because the investment in an auto level, a tripod, and a grade rod is not that much.
One more
For
good
150
little whack.
bucks, you can do this job.
Yeah, it's just barely off. That's probably good enough.
But if get some elevation change on a site like this.
Pretty cool.
So for a small area, a pad like we're doing right there probably makes sense to make that kind of investment in an auto level. Now, the other thing that a lot of people use is they won't even use a grade rod. They'll just use some kind of 2x4, just with some markings on it to get elevation. So grade rods, are important because it gives you the reading, especially when you're very far out. They're easier to read when it's very far out, but and most people do use a grade rod. But this gives you an opportunity when that customer comes in and you find out that he's doing a small pad, a small residential job, or even just widening the road by the distance of the building. You'll see these, and I tell you, look when you see, even on interstate jobs, you'll see them using auto levels all the time. When they do short distances, when they've got put in a sewer line because they've had some kind of breakage or something like that, when they need a determinate grade, they will use this for an auto level for short distances. There's hundreds of thousands of these sold every year. But a more efficient way of doing it, and a more productive way, is using a laser. So I'm going to turn on this laser over here. So remember, first of all, we had 3 wheels, right? I had to level that auto level. When I hit this button right here, I've got the head is, you can't probably hear it, but there's some motors going on inside. They're leveling themselves. So now, as soon as that gets level, this laser will start rotating. There's 2 types of lasers that for rotating lasers that you guys should be selling. One is exterior lasers, and that's a laser like this, which you can barely see the laser beam, and it's strictly a level beam. And then there's and we'll show you tomorrow because it's easier to see inside the building. There's a visible beam laser, which has a level beam that's visible, but it also has a plumb beam coming out the top. Now, the reason you would want to use this laser in a exterior environment is because they don't really care whether the moon is plumb to the earth, right? And the second reason is you don't need to spend the extra money for a diode that's a visible beam diode. Lasers come in different ranges, anywhere from 1,000 to 1,000 foot diameter to 3/4 of a mile. So I mean, they're and different accuracies. This one in particular right here is a 1/16 of an inch at 100 feet. Now, 1/16 of an inch at 100 feet is as accurate as you can get with a laser for the most part, because you have the curvature of the Earth problem, right? Oh, my receiver's down here. Sorry. Typically, your laser is going to be set up something similar to where we are right here. The project is worked over in that area, because you want typically the contractor puts the laser in a safe environment away from all the activity. Exterior lasers have to use receivers because you just can't see, human eye cannot see light outside. And another question you might get, which I get this question about once every 2 or 3 months, is a contractor wants to have a visible beam laser outside to do a particular job. And I had this last week, actually that on the flatness of concrete. And, can I buy a green beam laser? Doesn't make a difference. Green is brighter than the human eye. It's 4 times brighter than the human eye. But it's for inside work. If you're doing a Marriott ballroom, it's a great laser to use because you can see it that easier. But if you're working outside, the human eye cannot see any laser light outside unless you're working at night. So what I'm going to do here is I've got my receiver. So remember, you have to have a receiver when you're operating. I'm going to turn the receiver on. This particular one calibrates itself when you turn it on. And then I have different, we call dead bands. So So dead bands, all receivers, I'm not showing anything that's proprietary to our company, but all lasers have a dead band, or receivers have a dead band. And that, excuse me. And that's the plus and the minus. If you can see, this is my on-grade reading right here. See that line? This line right there. So that's going to be where when I set this, I'm going to show you. So when I set this laser up and I receive that beam in, wow, it's already secure. So when I set that laser up and I get my on grade, there's a solid line on this point, and you hear a solid tone. This is, this is how all receivers operate. Okay, so when you can hear is one tone when I get up to my on grade, it goes solid, and then it goes to a different tone. You hear it? It's going slower. So there's two different tones, and that allows the user, as he's doing his elevation reading, he doesn't have to look up at his receiver. He can go, okay, I gotta go up, down, I gotta go up, down, right? So what I'm gonna do initially is, instead of taking my reading, I've got the same ability here, which I've already aligned with my gun sights, to my hub. Now I'm going to go down there now. We're all going to walk down there to the hub, and we're going to take the readings down there. And keep in mind, what's different here? The difference is, when I did the auto level, how many people did I need right now? I needed somebody behind that auto level. At least two people. There you go. So I'm going to let one of you guys do that. I needed at least two people to take the readings, because I had one person behind that auto level and one over here holding the grade rod. Now I'm doing this. I need you to move a little bit that way, because we do need to have the visibility of the beam. I have one person doing the job. So they've come over here. They've put this receiver on the grade rod, which we would have done beforehand.
Somewhere in here.
Trouble with the sun.
There you go. There you get in range. You're high.
So what? Now that's a good point. So now I have an indicator that I'm high, right? If you come here close to me, you'll see that there's a little V facing down, plus the tone. And in this case, for this receiver, it tells me how far I'm off. 1 inch, 1 1/16 inches.
What does it tell you on the back as well?
It tells me on the back as well. But I'm gonna change this for a minute, because typically when they're doing concrete, this is a 1/16 of an inch accuracy, which is a pretty tight dead band. Remember that's plus or minus this point right here. That's pretty tight. If you're doing concrete work, they're usually working at a quarter or a half. So I'm gonna just change this, and the way I do that is just change that to season 8 and a quarter. So we're just gonna change that real quickly. And if you're demoing, it also makes it easier for the demo. This happens to be right there.
Man, nailed
That's
it.
perfect.
And then this little dot right here will tell you if you got this centered.
That's exactly right. So now, remember how somebody had mentioned, well, if you held the grade rod level, it would be different. I have a level vial right here that you can get your reading. So now, I've got my on grade, my solid tone, my level vial, and I'm ready to go. I want you guys, I'm going to take this around because I know you guys didn't get a chance to see that level vial that we have in the auto level. This is the same thing. So you can just kind of walk around. I'll show you that. So this is the vial. This is when we had on the auto level, we had to get it in. You had to get it within the range of this little vial. It's right there. So once it got in the range, my benchmark on my hub, and now I'm going to come back over here. And actually, I think we were off a little bit. It's got to come up just a hair.
That's a little harder.
Yeah. So the point point is here, this is more accurate than that auto level, right? Because it's giving me my reading, and we could have. That's okay. Don't worry about it. Well,
You still toe?
yeah. I mean, it would.
That right there's teamwork. Should go up.
There you go.
Well, what do you need? I mean, it doesn't need much.
1/10 of an inch.
It's been a story of my life.
You're just
Been that way since my honeymoon.
You're here. We have a mixed crowd here. So now I'm going to go around this the batter boards, and I'm going to take my reading with one person, and it's going to tell me. And how far I need you to move left or right. You're my laser. So, and what is it also giving me? It's 360 degrees, right? Since that's rotating here, if I have my batter boards at the other side, I could take the readings there or over here or over there or any readings. So, got my batter board set up. What I can also do is take my points anywhere on my site to level it.
What's your max range from the laser?
It depends on the laser. This particular laser is 1,650 foot diameter,
Oh.
but I mean, on ours, everybody makes a lot of lasers, but our longest laser is 6,000 foot diameter. But those are very expensive lasers that are used for like off ramps on freeways or agriculture. Typically, that laser right there, like a 1,650 to 2,600 feet, is what a typical STAFTA evergreen member would sell, because they're usually doing buildings like this, or like the Amazon building we saw in there. The highway work is you're going longer distance, right? That one I'm talking about with the 3/4 of a mile, it's also used on that Somero screed that you saw in that that power screed that they had.
Yeah.
So
How much is the accuracy affected with distance? Because I assume, this is a question, that the laser gets broader the wider, the more distance you go.
So usually lasers will start, like a Home Depot. We don't sell to Depot, but their type of lasers, their accuracy rating on that will be roughly 1/8 of an inch at 100 feet is what they rate. But who knows what the hell comes out of there. They'll go down to a 1/16 of an inch at 100 feet, and then so if you're out
Just
1,000
double it
foot
every 200, or every 100 foot, just
it's a
double
16.
it. So
Yeah,
it
and
should be
that's
an eighth of an inch, or an eighth at 200.
right,
And
right, and that's how it's measured in arc seconds, which
yeah,
you got to be a rocket scientist, and I don't understand it. So
I can't believe
anyway,
you don't
it was explained to me 12 times, but I understand 1/16 of an inch at 100 feet. So, but you've got the curvature of the Earth, believe it or not, and that's giving you that in accuracy. The other thing that can affect a laser, which you want to look for, is temperature. Like today's a good example. I don't know what the temperature was when we started, 45 degrees maybe, when I set these things up, 45 degrees or maybe around there. And it gets up to, it's going to be 80 today, right? So what happens with a laser? And what happens with materials? They expand and contract in a laser. I mean, there's plastic and metal in there, right? So as those things expand and contract, you're going to have that laser move in space. It's just the physics of it. So things like, you get, and this is where when you're selling, and this is whoever's your laser you're selling, whether it's ours or anybody else's, you get an inexpensive laser, a $700 laser, and you're doing a large building, and he has that unit float, that in essence float, at noon, he's getting a different elevation of on grade off of that hub than he did at 7 o'clock in the morning. So now he's saying, he's pouring different, or he's preparing his site at a different elevation. So you want to look for things like, that laser right there has something called temperature compensated. So every 5 degrees Celsius, that laser will bring itself back to its on grade. So it gives you the acceptable standards that the engineers are going to build a building to, and you don't have those inaccuracies, which would cause puddling and stuff like that you saw in the video earlier today. So that's the type of thing that you want to look at. What we're going to go through tomorrow is like kind of the questions to ask, because there's only a few questions you need to ask from buying a laser. And we'll go through that. But do you guys have any other questions on lasers in general, or applications, and okay, you ready to move on to the next part of this state question? So if we look at this is a great example. It's probably a manhole somewhere around, but you if we look at this parking lot, you can see just by looking at it, it flows down to this point. It's got, I don't know where it's probably going over to that corner right there. It's probably where the manhole is. So the water is going to flow down. In this case, they probably want to flow down and over to go to the manhole. So there's two types of grade, or grade lasers. There's a single grade, which will give you basically like a ski slope. We're coming straight down from that building down to here at a percent. Or in this dual grade, which gives you what we call X and Y axis. So I've got my single grade coming from the street down to here, but then I want it to go over there, so I've got it, my laser beam dipped in this direction and this direction, giving me a plane of light coming over to that corner. Okay, it'll be easier to understand that concept tomorrow when I show you a slide of this. But in this case, what I want to do is a couple things. I want to get that grade, so I have it coming down to that point. I have a grade laser because I've shown you what that laser is a flat laser. So that gives you just a flat plane of light. It's basically 0% in this direction, 0% in this direction. It's giving you an elevation point. It's what contractors use for doing, you know, the pad of a building, right? They don't want it to go left unless they're doing some kind of runoff of the doors or something like that. But grade is important, especially when they're outside doing parking lots and things like that. So one of the questions that you guys want to remember when somebody comes in and he's looking and he's doing a commercial building like that Amazon building, ask them the question is, do you ever do grade? Because about 75% of the time they'll say, yeah, I got to do the parking lot. Well, how do you do grade? You can do grade by taking a flat laser and having a flat laser beam like I have spinning right there. And I could say, all right, I need to go 1 foot at 100 feet. Now, what is that? 1 foot over 100 feet is 1% grade. Or you could take, and that's going to be a calculation, and you saw with a grade rod, even with a laser, that's not going to be a precise measurement, right? But what I can do with a grade laser is I could put that 1% grade into the grade laser. So that's now what we call self-leveling at grade. When I say self-leveling at grade is that level, that laser, I'm going to show you this. You'll put in 1%. It's going to take that laser beam and it's going to dip it, the head on that at 1%. And once it does that, it's going to start rotating. Once it rotates, it now, if it's knocked, just like this laser, if it's knocked, which I didn't show you, I probably should have, we'll show you over there maybe. But if it's knocked, it's going to stop rotating unless it can come back to its level position. That will do the same thing. It self-levels at grade, so if I have it spinning and I knock it, it's going to come back to 1% and it will level at 1%. So that's what self-leveling is at grade. And that's an important concept. You got to check, make sure that the lasers you're selling are doing that, because some lasers, they put themselves into what we call the manual mode, dip themselves, and if you knock it, I want to show you this, and if you knock it, it won't stop rotating. So if I take this and I go like so, it's gonna, you can see this is gonna stop. If it can't level itself, it's gonna stop rotating in a minute, unless I left it within the range. And see, it's beeping. See that? But if I take this button right here, I've got a manual button here. So in essence, I'm whatever I would have dipped this to. Let's say that's 3%. I can hit this button like so, and now I put it into a manual mode. And you see, can you see that beam, that head flashing? So in many grade lasers, and this is important, that what they're doing is they're taking that laser and they're taking it out of self-leveling, like I did right there, and they're putting them into a manual mode, like I've just done now, and they're going to whatever percent, the 1% that you put in, and they're spinning. So if you knock it now, see how that's continuing to rotate? It's because I have it in the manual mode. So that's an important, I'm going to turn this off right now so we don't have two lasers going. That's an important feature to talk about, or check with your manufacturer, because that you really want to go with something that is self-leveling at grade, because otherwise that contract, especially when you're doing a large job, you got 3 and 4 people on the job and together, hit it with a ladder or whatever. You've got a lot of activity going on, and you want, if that thing is off, you start doing. I had a customer come up to me, a user come up to me on a job site, and tell me this exactly happened to me, and he had to fire a guy. He goes, it was knocked. He was reading the wrong elevation, and he laid the entire job out at the wrong elevation. And a building like this, well, it won't take that long to redo. But you get a building like that Amazon project, that's going to cost you a lot of money. So when we come over here, I mentioned, well, we have the grade rod. Remember I mentioned that there's the two types that you guys will principally use it selling. You won't be selling probably metric. But in this case, I've got 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 5 feet. So the other one went intense. That's what you see as a inch grade rod. So that's so I have. Can I hold that? So I have in this case it's a grade laser. I'm going to turn the laser on, and it's going to take readings. And if you came over here, you would see. Well, you can see right here.
This is the 2-axis X and Y.
This one has X and Y. That's a good question. You can buy them in X. You can buy them in Y. In our line, there's usually about percentage-wise about a 10% difference. Okay, I'm actually about 20% difference. It was a couple $400 or something. If it's me buying it, it's a grade laser. Usually, a good grade laser is anywhere from $2,000 up, right? I would recommend buying it to the user to get the X and the Y. Because he's going to use it. If he says all I do is residential houses and it's a driveway, you probably get away with putting something like that into grade. But then it's an X. He would X. But most my recommendations to a user is, and that's what we see as our numbers in general, is a dual axis. Okay. So what you didn't see while I was yapping, any other questions on that? While I was yapping there was there was two little dials here, or little thermostats that I saw on my remote here, and the unit was taking its temperature for that temperature compensation that I mentioned that. Plus, it was leveling itself. So once it leveled itself, took its temperature, those readings are in the software now. It knows I'm ready to go. So right now, this laser is rotating in, this would be the y-axis and the x-axis. And I want to show you this because, let me just get rid of this. I want to see if you guys can figure out something. With me? What I'm doing now is I'm putting in I put in 0 degrees in my y-axis, which is always in this direction, or 0 degrees in my x-axis, okay? So when it levels itself now, I have a flat beam of light. Just like that unit over there, 1/16 of an inch at 100-foot accuracy, okay? So what I'm gonna do is I wanna take a benchmark, and that benchmark in this case, I want to set this laser up so that it is as close to my X and my Y axis over the point that I want to read as I can. So if we turn this receiver on, it's calibrating itself. Once it calibrates itself, it's all set. So now if you come over here and you take your reading, I'm going to put this a little louder so everybody else can hear. So if we just move this up a little bit. Okay, so now I've got, that's my point I'm starting from, right? I've already in this case I want to match these points. I don't know what this grade is right now, but for the sake of what we want to do right now is we're going to put in a percentage grade, and we're going to say, I'm going to bring it down here. We're going to say we want 2% grade. So if it's rotating, you can see it's not. I know right now because I'm not getting any sound, and I don't see anything on that receiver, or okay, the very top of it. That level plane of light is going somewhere up here. It's hitting at the very top of this, right up in there. What I want to do now is I'm going to put in. I'm going to let you do this. I'm going to put in, let's just say I want 2% grade here for the sake of, I know this isn't, well, or let's put 3%. So I'm going to say, that's my angle, I'm going to hit enter. I want to come
Perfect.